Ever wondered how cities predict traffic jams or optimize road networks? The answer lies in vast amounts of traffic data, but what happens when that data is incomplete? Today, we're diving into a groundbreaking solution called STAMImputer, a smart system that fixes missing traffic data so cities can keep moving smoothly. Let's start with the problem. Traffic data is collected by sensors, cameras, and devices, but sometimes this data goes missing. A broken sensor, bad weather, or network outages can create blockwise missing data, gaps that span entire time intervals or spatial regions. These holes disrupt predictions for traffic flow, congestion, or emergency responses. Traditional methods struggle here. They often treat time and space separately, like analyzing traffic at one intersection over hours, but ignoring how nearby roads interact. Plus, many systems rely on static graphs, fixed maps of road connections, that can't adapt when traffic patterns shift. So how does STAMImputer solve this? Think of it as a team of specialists. At its core is the mixture of experts, MOE framework. Imagine different experts working together. One focuses on temporal patterns like how traffic changes over hours, another on spatial relationships, how roads connect. When data is missing, the system dynamically assigns the right expert to handle the gap, balancing time and space like a well-oiled machine. But here's the clever part. STAMImputer uses a new technique called LrSGAT, low-rank guided sampling graph attention. This isn't just about connecting roads, it's about prioritizing the most important connections. For example, during rush hour, a busy highway might influence nearby streets more than usual. LrSGAT identifies these key relationships in real time, creating dynamic graphs that adapt as traffic changes. It's like having a GPS that updates itself based on current conditions. The results? Tests on 4 real-world datasets show STAMImputer outperforms existing methods by a significant margin. It's not just faster, it's smarter, handling complex missing data scenarios that other models can't. Whether it's a sensor outage or a sudden traffic surge, this system keeps the data flowing. So next time you're stuck in traffic, remember, behind the scenes, algorithms like STAMImputer are working hard to keep cities moving. And who knows? Maybe this tech will one day power your own smart commute. Thanks for watching, stay curious, and let's keep exploring the science behind the world around us. Ever wondered how AI can predict missing pieces in complex data, like filling in gaps in weather patterns or traffic flow? Today, we're diving into a groundbreaking framework called MOE, short for Mixture of Experts, that's revolutionizing how machines handle spatio-temporal data. Let's break it down. At its core, MOE is like a team of specialized experts working together. Imagine a system where different experts focus on distinct aspects of a problem. One might analyze historical traffic trends, while another deciphers real-time road interactions. When data is missing, the system activates the most relevant experts, combining their insights to reconstruct the full picture. This approach mimics how humans tackle complex tasks, leveraging specialized knowledge to solve bigger challenges. But MOE alone isn't enough. That's where LrSGAT comes in. This technique uses a low-rank matrix decomposition to simplify the vast web of road connections. By identifying the most critical relationships, like major highways influencing local streets, it reduces computational load without sacrificing accuracy. Think of it as a neural network that learns which roads matter most, dynamically adjusting its focus as conditions change. The result? A system that's both efficient and adaptive. Unlike static models, STAMImputer evolves with the data, making it ideal for real-world chaos. Whether it's a sensor failure or a sudden accident, the algorithm fills the gaps with precision, ensuring traffic predictions remain reliable. So the next time you navigate a city, remember, AI isn't just predicting traffic, it's rebuilding the invisible infrastructure that keeps everything moving. Stay curious, and let's keep pushing the boundaries of what machines can learn.